Hello, geometry friends. Today we're going to do a lesson about an introduction to right triangle trigonometry and three trigonometric ratios. Now, you've probably heard the word trig before, but you've never really done anything with it. Or maybe you've noticed on your calculator or your phone, there's a button that says trig or sin, cos, and tan. And so what we're going to do today is define those words, define those phrases, those operators, and then learn how to work with them. So that's what we got. So we are on day 8, which should be page 25 in your packet. And so what we're going to do first is kind of look at this page and develop a definition. So if we look at this, what I've done here is I've actually given you all the answers. And what I want to do is walk you through how to kind of use what you know to figure out what you don't know. So this says sin A, which is pronounced sine A, equals 3 over 5. Okay, well, I notice that there's an A here, and that says 3 over 5, and those happen to be sides of the triangle. Okay, that's pretty cool. So sin A equals 3 over 5. I'm going to scroll down here, and then this one says sin X or sine X is 24 over 25. Okay, so here's the X, there's the 24, and there's the 25. Now, if I look at these, what am I noticing? Well, I'm noticing that the bottom number is like the slanty side, also known as the hypotenuse. And I'm noticing that the top number is like far away from the letter for the angle. All right, let's see if that continues to hold true. So now I have sine t equals 12 over 13. Okay, so here's t, and here's 12, and here's 13. Well, yeah, the 12 is still far away, and the 13 is still the hypotenuse. So what I'm realizing is the sine function from a certain angle, the numerator, the top number, is the leg that's far away from that letter, and the bottom number is the hypotenuse. So if we come down here to the bottom one and I want sine C, I'll say, okay, C. The number on top needs to be the number that's far away. That would be 8. And the number on the bottom is the hypotenuse, which is 17. So sine C, based on the pattern, looks like it's going to be 8/17. Okay. Now let's do the next one. So the next one says cos. So the next one says cos A equals 4/5. Now cos stands for cosine, and it says the cosine of A is 4 over 5. So the cosine of A is 4 over 5. So I still have a hypotenuse as the bottom, but instead of using the 3, I'm using the 4. Okay, so it seems like it's the other leg divided by the hypotenuse. Let's see if that holds true. Cos x. All right, well, cos x equals 7 over 25. Yep, that's the other leg in the hypotenuse. Cosine t. Well, here's t. 5 over 13. Yeah, it's the other leg divided by the hypotenuse. So let's do it down here. Cosine C is going to be the other leg divided by the hypotenuse. So that'll be 15/17. All right, now tan. Tan is short for the word tangent. And if we want to do tan A, let's do this in blue here. Tan A is 3 over 4. Okay, so I'm not using the hypotenuse at all this time. Here's A, here's 3, here's 4. So it's the far away number divided by the close number. All right, let's try it down here. This one says tan X equals 24 over 7. Okay, so X, 24, 7. Yep, so I didn't use the hypotenuse again. Far away number over close number. And then tan T, so here's T, far away number over close number, and I didn't use the hypotenuse. Okay, so if I want tan C, I want to use the far away number over the close number and not use the hypotenuse. So 8 over 15. This page was all about patterns, about figuring out that we look from the angle and then use numbers based on their position from that angle. So now we're actually going to define it. So if you turn to the next page, we are going to define these as sine theta. Now, if you're looking and you're going, what the heck is that 0 with a line through it? That is the Greek letter theta. Okay. And it's a letter we often use when we know that there's angles. So before, when we did like a squared plus b squared equals c squared, if you ask anybody, probably even an adult, and said, hey, what's a squared plus b squared equals c squared? They might remember that's Pythagorean theorem because we often use a, b, and c for the sides of a right triangle. Theta is just a Greek letter we use when something that we're missing happens to be an angle. X we use in algebra when things happen to be, just a number in an equation, but theta we use to represent an angle. All right, so anyways, sine theta means if you want to take the sine of an angle, okay, and that angle is in a right triangle, sine theta, we said, was the side that was far away divided by the hypotenuse. Now, we have a better word for it than that. It's called the opposite side. The side that's far away is called the opposite side over the hypotenuse. Okay. And then cosine, instead of using the opposite side, we use the one that was close by. In mathematics, the one that's close by we called the adjacent side. So cosine is adjacent over hypotenuse. And then for tangent, we use the far away one divided by the close one. So that was opposite over adjacent. Okay. And there's a little mnemonic device we use for that, and it's called Sohcahtoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right. And if you want to write Sohcahtoa as fractions, you could write it out like this. Okay. But I highly encourage you to memorize that word, that acronym, Sohcahtoa. Know how to spell it, because we're going to use it a lot to figure out, wait a minute, what am I supposed to divide here? Okay, so make sure you learn that one. All right, so down here, one of the things you need to know is opposite, adjacent, and hypotenuse all have to do with the perspective of an angle. Okay, so if I look at this circled angle and I think of that as my perspective, what you really want to think of is that you personally are standing here at angle A and looking at the triangle from that perspective. So from the perspective of A, the side that's furthest away is called the opposite side. The side that's not furthest away but still forms the right angle, that's called the adjacent side. And then the side that's across from the 90-degree angle is your hypotenuse. Now, your hypotenuse has nothing to do with your perspective. So, like if I come over here and put myself at B, 13 is still the hypotenuse because it's across from the 90-degree angle. The hypotenuse is the hypotenuse is the hypotenuse. It doesn't matter where you're standing. All right. Now, what's opposite from B? Now 5 is opposite when I look from angle B, and 12 is the adjacent. Because my perspective changed, those labels change. Okay, so when you have sine, cosine, and tangent, it's always from the perspective of the angle that you're using. Let me show you what that means. So if I come down here and it says find the following trig ratios, sine A, cosine A, tan A, I'm going to redraw that triangle just because I want to, and I'd like you to do the same. So here was A, here was B, here was C. And we said that's 12, that's 5, and that's 13. So if I want sine A, cosine A, and tangent A, it means I consider my perspective from this angle. And then I say, all right, sine A. Well, I had Sohcahtoa. So sine A will be the side opposite from A divided by the hypotenuse. So the side opposite from A is the one furthest away, that's 12, and the hypotenuse is 13. Cosine A, ca, stands for adjacent over hypotenuse. So that's the thing next to A, 5, divided by the hypotenuse. And then tangent, toa, tangent A is opposite divided by adjacent. So the one that's far away, 12, divided by the leg that's close. Okay. If instead I say, you know what, I want sine B, cosine B, and tan B, I can do that too. So if I come over here and I look from the perspective of B, and then I want to do sine again, sine is opposite over hypotenuse. So opposite from B is the one that's furthest away, that's 5. My hypotenuse is still 13. Cosine is adjacent over hypotenuse, so that's the thing next to B divided by the hypotenuse. And then tan B is opposite over adjacent, which would be 5 over 12. You have to know how to find these perspectives and figure out where these fractions go. Okay, that is muy importante when it comes to trigonometry. All right, and then it says which ratios are equivalent. Oh, look at that. Some of these are the same. Cosine of A is 5/13, and so is sine B. So cosine A is equal to sine B. That's pretty cool. And what else? Oh, look at this. And then sine A is equal to cosine B. And then it says, what's the relationship between A and B? Well, A and B are the two different acute angles in the triangle. So A and B are the acute angles in the right triangle. And in fact, since all the angles in a triangle have to add to 180, that means 90 plus A plus B is 180, which also means that A plus B equals 90. We're going to come back to that. And then it says, well, we did sine A, cosine A, and tan A, sine B, cosine B, and tan B, but we never did anything for C. Why is that? Well, here's why. If I look at the perspective from C, and then I had to do opposite divided by hypotenuse, opposite is the side across from C. The side across from C is 13, but the hypotenuse is also 13. So that would be weird. Opposite divided by hypotenuse would be 13 over 13. And then if I tried to do cosine C, I'd have to figure out the adjacent side. Well, adjacent means next to, but not the hypotenuse. How would I choose what's the adjacent? 5 and 12 are both the adjacent, and everything just crumbles. Okay, so why don't we write out the trig ratios for tan C? It's because in that point, opposite would equal hypotenuse, and adjacent is ambiguous. I don't know which one it is. I need more information. So you will never see us write out Sohcahtoa ratios for the right angle. Okay, now I feel like this video is getting kind of long and I may want to pause it here. It is, it's 13 minutes. So here's what I want to do right now. I want to take a quick pause in this video and hope that you guys understand what's going on. This is our introduction to trig. Okay, so what I want you to do is stop here and then you're going to do the follow-up questions in the form. All right, so hopefully these trig ratios make sense, and we will come back again later with some more examples. That is all, my friends. I hope you're having a good day. We'll talk again soon.